Welcome to our channel. Today we're diving into the fascinating world of chaos theory and exploring how it explains the intricate workings of nature. Now, chaos theory might sound intimidating, but in essence, it's a branch of mathematics that examines complex systems. These systems are characterized by their sensitive dependence on initial conditions, which in layman's terms means that even the tiniest of changes can lead to vastly different outcomes over time. Imagine the path of a meandering river, the formation of a cloud, or the growth pattern of a tree. All these are examples of chaotic systems. And what's truly fascinating is that within this apparent randomness, chaos theory allows us to discern underlying patterns and structures. So, as we delve deeper into this intriguing field, remember this: from the flutter of a butterfly's wings to the turbulence of a river, chaos theory unveils hidden patterns within seemingly random phenomena. One of the key concepts in chaos theory is the butterfly effect. Imagine a butterfly flapping its wings in Brazil, which stirs up tiny changes in the air. These changes multiply and grow, eventually causing a tornado in Texas. This is the essence of the butterfly effect. A minuscule disturbance in one place can trigger a chain of events leading to a monumental outcome elsewhere. This idea suggests that a small change in one part of a system can have large effects elsewhere. Nature is filled with fractals, geometric shapes that repeat themselves at different scales. These seemingly complex shapes are in fact quite simple, as they are formed by repeating a basic process over and over again. The beauty of fractals is that they exhibit self-similarity, meaning they maintain the same shape no matter how much you zoom in or out. Let's consider a tree, for instance. A tree is a fractal because each branch is a smaller copy of the whole tree. Similarly, if you look at a coastline from afar, it appears jagged and irregular, but as you zoom in, you'll notice that every smaller section of the coastline maintains the same jagged pattern. Snowflakes too are fractals. Each arm of a snowflake is a smaller copy of the whole snowflake, creating a stunning pattern of self-similarity. So next time you're out in nature, take a moment to appreciate the fractals around you. Trees, coastlines, and snowflakes all exhibit self-similarity. Chaos theory helps us understand turbulent behavior in fluids like rivers and clouds. This branch of mathematics unveils the peculiarities of turbulence, an ever-changing, unpredictable, and yet mesmerizing phenomenon that we see in our daily lives. Turbulence is an example of a dynamic system, a system that changes over time. From the swirling patterns of a tornado to the frothy rush in a river, dynamic systems embody the essence of chaos theory. Each of these systems is sensitive to its initial conditions. Just a slight variation at the start can lead to dramatically different outcomes, making these systems inherently unpredictable. The unpredictability, however, doesn't denote randomness. Beneath the apparent disorder, chaos theory uncovers underlying patterns and structures. It's this mix of predictability and unpredictability that makes dynamic systems so intriguing. So, the next time you see a cloud shifting forms or a river changing its course, remember that it's chaos theory in action. These systems are sensitive to initial conditions, making them unpredictable yet fascinating. Through chaos theory, we can appreciate how natural patterns emerge from non-linear interactions. Think about the harmonious dance of birds flocking in the sky, or the synchronized movement of fish in the ocean. These patterns are not directed by a single leader. Instead, each individual reacts to its neighbors, leading to complex group behavior. Similarly, consider the sprawling beauty of galaxies or the intricate growth of ecosystems. These are all examples of emergence, a process where simple interactions lead to complex patterns. From the formation of galaxies to the growth of ecosystems, chaos theory sheds light on the beauty of complexity. In summary, chaos theory provides a powerful lens through which we can perceive the interconnectedness and complexity of nature. This fascinating branch of mathematics offers a portal into the intricate dance of order and randomness, unveiling the hidden beauty in our world's most complex systems. From the ethereal flutter of a butterfly's wings to the awe-inspiring turbulence of a river, chaos theory brings us closer to comprehending the sublime patterns that permeate our natural world. It's a testament to the delicate balance and intricate interplay of forces that shape our universe, revealing that within apparent randomness, there is a profound underlying order. So as we continue our journey of discovery, let's marvel at the beauty of complexity, Appreciate the elegance of chaos and strive to understand the sublimely intricate language of nature. And remember, every new insight brings us one step closer to unraveling the mysteries of our universe. Thank you for joining us on this exploration of chaos theory and its profound implications for understanding nature. Don't forget to like, share, and subscribe for more enlightening content on science and discovery.